Okay, so we have Simon, and he's going to continue with the okay.
Does it work? Right? Nothing happens? No?
It's not reacting to page up and page down.
Yeah, or just stand here. Just stand. Yeah, I can do that.
Is it? But it's turned on, right? Yes, it's on. And
Yeah.
so maybe it's ocular and not reacting to page up and page down.
Yeah,
So let's
do this. Okay, so I can go? Yeah? So this is sort of an extra add-on to the stuff I was talking about before, because the plan was for me to talk both about text analysis in the way that I did before, but also a bit about network analysis, how to use that. And this is with data from the GE17 hashtag, the British general election. That was in 2017. You probably remember it was this, I think it's called a snap election. That was called by Theresa May, like an early election. Before an election had to take place, she called this election to try to increase her support ahead of the negotiations about Brexit and so on. And in the end, there was this big campaign by Labour, Jeremy Corbyn, with this for the many, not the few. There were lots of debates about healthcare and about Brexit and about immigration. And in the end, I think she didn't. She won the election, but she didn't get more support than she had before. If I remember correctly, it was actually diminished a bit. But this was also just like me to an occasion to get a data set to work with, and I did this study before. I wrote that exact data collection script that I showed you before, but it's the same method, basically the same underlying architecture. It's focused on the Twitter API. I used Python code, and I used the Tweepy library, which is the Python library that is also referenced in the scripts that I showed you for this Back to Future idea. So I'm going to discuss some examples of how we can use network analysis for working with Twitter data. Then we're not working with contents of the tweets, or we will do that as well. Actually, I'll talk to you also about that. But also with metadata, like user account names and who posts what and who mentions whom and so on. And I won't do anything except from very briefly right now about social network analysis in general. But connecting to this idea about digital sociology that I mentioned before, I mean, social network analysis is sort of, on the one hand, it's connected to like graph theory and maths and that type of thing, the network analysis bit. And the social network analysis bit goes back to like ideas in classic sociology, the thing usually credited for the piece of theory usually credited in sociology for sort of inventing social network analysis is the theory about dyads and triads formulated by Georg Simmel, who is one of the classic sociologists, where he basically said that if you have a group of two people, a dyad, the dynamic is different from if you have a group of three people, because then there are lots of other relationships, or at least some other relationship possibilities possible. A can communicate directly to B or directly to C, or A can communicate via C to B, etc. And that was his idea, that the social formation will change the social dynamics, and then that can be scaled in many different sizes and volumes. And there are, of course, these, let's say, classical, most well-known network analysis concepts as well. There's the notion of, for example, network structure, where we have this idea of centralized networks. Can I draw a bit? Yeah. We have something. If you look in network analysis teaching textbooks, there's usually this sort of illustration where it said that this is a centralized network, and then you have sometimes also decentralized networks. So in the centralized network, this is sort of ideal types, but then you have basically one central hub. In decentralized networks, you have some centers that are sort of combined versions of this. And then I'm seldom very successful at drawing these, but then you have the distributed network, where the idea is that everything is connected to everything else. And sort of as a side note, this was what was sort of the goal to achieve when the internet was created as a military and academic project in the US in the 50s and 60s, to create a network that was not vulnerable to like an attack, for example. If this node disappears, then the network is dissolved. But that's sort of a sidetrack. I mean, the idea is that in social network analysis, we can be interested in network structure. For example, looking at a Facebook group or communication under a Twitter hashtag, it's interesting to see, is this a decentralized communication structure? Is it a centralized communication structure? Or is it more or less tending towards the distributed type of network? And the one on the right is much more resilient and much more tactical, has much more such potential, and so on. And in my own studies, I have some examples. I didn't bring them today, but I did an analysis of the McDonald's Facebook page and the Occupy Wall Street Facebook page around the same time in 2013 or something. And the McDonald's page looked like this, and the Occupy Wall Street looked like this. And then you can find some sort of in between versions as well. And when a company, for example, or someone who wants to affect people's thinking, either through marketing or politics or whatever, there's sometimes this deterministic idea that as long as you're on social media, you will deploy the type of processes that are on the far right of that image. Like, people will be like a beehive communicating and interacting, while it can very well be like the more mass communication model of the centralized network. So it's interesting to see. You collect data for some sort of setting and you look at the network structure. Then there's the idea, which was made famous in this paper by Mark Granovetter in the 1973 paper, I think, in the American Journal of Sociology, about the strength of weak ties, which is also very famous in sociology, where it's the idea that, yeah, maybe I should draw again. Should I? Yeah, his idea was in this paper that you have groups that are sort of embedded in a network where sort of everyone knows everyone, like friend groups, things like that. Could be clusters within a class or within a community, whatever, and they may have different structures like this. And these are the strong ties. They are sort of marked by this embeddedness. And then there may be the weak ties that go that direction, for example. And he highlighted the importance of these weak ties, where there's some sort of relation of brokerage or bridging, where, for example, someone like this node can reach this node, but only through these two, which is also in network analysis terminology then focus on the, or relates to the metric of betweenness, like you have a high degree of betweenness when many pairs in the networks have their shortest paths going through you, while the network degree has to do with the number of connections. So technically you can have someone that has a low degree but has a high level betweenness because of these weak ties that are important in bridging social groups. Lastly is this, we also have this theory about small world networks and this sort of part folklore, part theory idea about 6 degrees of separation, where there was this experiment in the 60s made by a social psychologist called Stanley Milgram, who did this experiment by sending letters by sort of old school mail, and it had to do with the letter was supposed to reach someone, a defined person, and it was sent to someone, and there were some rules like you can only send this to someone who you know on a first name basis or whatever, and who you believe is more likely to be closer in terms of social circles to the one who's in the end of the chain. Let's say if I got the task to get a letter to Donald Trump, maybe I should send it to someone I know who works in politics or who lives in more central place than Umeå in Stockholm, for example, and try to, I don't know. And his result was that roughly 6 steps was what it took. Like anyone is connected to anyone else with roughly 6 jumps. And then this was replicated with the electronic communication by Duncan Watts is his name, and his research group in the 90s, I think, or early 2000s, maybe late 90s, or somewhere around the turn of the century, where they showed about the same thing. And this also has to do with that the internet has been said to have these small world characteristics, which is a certain structural property of a network that it sort of makes it makes the world smaller. So this is sort of a small theoretical thing. I said I won't say very much, but now I've been talking quite a bit about this because I think it's interesting. But I think it's not in the slides, but it's an important addition because the things I do in the slides are quite basic. It's just like showing how to produce network graphs. But these are the types of issues, like is it a small world network? Is it a distributed network? Is it characterized by these weak tie connections? Does it have hubs? Are there important actors in this network? And we can also in network analysis look both at the network as a whole, but also at individual nodes in the network. To see if they have a certain centrality or whatever. But like I showed you in more hands-on manner in the previous session on the Me Too data, of course I did some parsing of this data and I picked out the stuff I was interested in. And this shows actually a bit closer something that was black box in the previous thing. Like when you get data from the Twitter API, you will probably see this in the raw stuff as well. You have in the Twitter data you have all of these different things. You can get information on in what time zone the user who posted the tweet was in. You can get the URL of the user, like the web address to their Twitter profile. You can see if they have a customized background image. You can see if they have selected a custom color for sidebar fill on their Twitter user. And you also get what they post, if you use an app or if they post from a mobile device and so on. If they have geotagging enabled, you see their coordinates. If the user is a verified user, with this little tick box you have with public figures on Twitter. I'm actually verified as well. I'm quite proud of that. It's possible. I said I'm a researcher. I do internet stuff. People know of me. Okay. You have to motivate. Give a motivation. So, but all these things can be interesting from like a sociological point of view. You can get the status. You can see how many times has this person posted, how many things. Many lists of like special interest lists created by other users are these people listed and so on. So there's many more than these. I think it's around 40 or something. And then I did some cleaning and filtering, of course, as I showed you before. So this is some of the Jupyter code, just giving you the idea. I chose these columns like some sort of generally sociologically interesting columns to move further with. We don't need all of this for the network analysis, but what date was created, was it created, something about the author, something about who is addressed by the tweets, like if you didn't reply to someone, is someone mentioned, does it have hashtags, does it link to media, what's the text, how many times has it been favorited. And this is important because if you stream tweets live, you never get a lot of favorites or retweets because you grab the tweet at the moment it's posted. So, I mean, on rare occasions, by chance, maybe you would have one favorite marking or something if there's merely a glitch in the system, I guess. But mostly, that data is only interesting if you go back, because then there's been time to aggregate replies or retweets or posts. And you can also get the language code. So then I create a data frame with these columns. And then to do the social network analysis, it's only these two columns that I'm interested in, because that's the basis for social network analysis. I mean, in order to produce a network graph, you need an edge list, which is a list of edges, which is the connections in network analysis language sense. So you have sources and targets. So for each tweet, in this case, we're not interested in what was said, we're not interested in when it was said, we're not interested in the background color of the profile page of the person who said it. We're only interested in this is an instance when someone, the source, said something to the target. We can also,
Just, I'm not 100% sure, but screen name is not the user identifier, correct?
There's a user ID, which is the number, like a string.
Yeah.
And then you have the user name, which I think is what you put, where you can put like your name with a space, like I put Simon space Lindgren, or that can be changed. And then you have the handle, like with the @ symbol, which has no spaces. You can use underscores and stuff, and that's the screen name.
Because it's changing time, so actually, if you use the screen name, I mean, maybe it's not affecting the results so much, but if you use the screen name, you can both think that two nodes are different because the user has changed the name.
Of course. So probably an even more like safe way would be to use ID numbers.
Yeah, actually, you might see this in class. So what I do for your problem is we take the user ID long, which doesn't change, and then we actually do string concatenation of changing screen names.
Yeah. So that's also a thing, because I think the name we can change several times a day if you want.
But the ID won't change.
The screen name, I think, may be connected to the ID, but
the screen name changes, but user ID
it does.
does not change.
Yeah. In this case, it's the screen name, and it's in reply to what screen name, because also getting these two fields, but then we can also switch to get in reply to the user ID. But this is also like a shortcut for visualization, because then if you want to show something like in these political debates and you don't want to anonymize accounts, you already have the IDs translated to the names, so you can plot them. But of course, you can also go via the IDs and get the names. Yeah.
Why are you interested in the name or the ID? Whether you more interested in location or like different town, what kind of content do they are subscribed to, and what kind of content they
That's sort of the metadata about users that can be interesting, like to overlay as data on the network. But in this case, I'm only interested in like finding that, like the connective structure of the network. So actually, no matter who they are, just see what type of structure does this network have. Is it centralized? How is it connected? Are there some people who are important? And then the next step, obviously, is to zoom in on those who are important, and then see, is this something that seems to be decisive for why they are important? Is it just simply their position in the network? Is it because they share some characteristic? Maybe all of them are official organizations, all of them are in the western parts of the world, or something like that. But in this case, it's basically a point just to boil it down to sort of the raw structure. So for the purpose of this particular thing, it's only these things that are interesting. And I mean, you probably come from very different backgrounds, and to some of you this is even too basic. But what you have is, with an edge list, you have a source and a target. So we have a user named A, and we have a user named B, and then we have a user name or an edge going from A to C, and then we have something going from C to D. If we get that data from all tweets, we will have an edge list like this that goes on. So when we produce the graph, we draw A, and then we draw an edge to B. Then we have the first line. Then we have another one going from A to C. Then we need to reduce the C and draw an edge like that. And then we have D, which goes like that. And then when we visualize the network, we can say that every time we find the same connection again, maybe we should make the edge wider by a certain parameter so that the network visualization shows this. And we can say that for every time that someone has an incoming connection, the size should increase. And that's usually something like that which is done. So you see like the import or the strength of a connection somehow by width and the importance of a node somehow by size. But that importance can be measured in different ways. So this is why we need this list. And once we have that one, I use this library in Python, in this case called NetworkX, which you can sort of see it's quite readable code. I decided that G is a graph, and then for U, V, and data, which means that I have my raw data where I have the sources and the targets, and I also have the data, because in this edge list that I have we've skipped that step, but I also calculated the edge. No, I'm calculating the weight here actually. Yeah. I go through all the edges and I create in the data sort of storage place in the edge variable. I create an item called weight, and then if it's more than one, then I sort of add to the weight so that we get a list where we have for each edge the source, the targets, and the number of times that it's occurred. And then we have this graph object. It was a bit messy, but you see, if you understood the thing that I drew on the board earlier, that was sort of the same thing. So these are the number of nodes, these are the numbers of edges, and this is the average degree. This is what NetworkX outputs by default. And I think this was 1.7 million tweets from basically the election night of 2017. Then you have to reduce the graph somehow, or at least it's often useful to do that. So you can get different properties. In this case, we look on the top of this slide. There are 2,165 connected components in this network. So basically, there are 2,165 different islands in this network. But if we look at the size of these islands, the largest one, the so-called giant component by network terminology, is 94,000 nodes, which is quite a large proportion of these 99,000. So sometimes we may be interested in what goes on in the periphery and how those different sort of outlying islands are structured, or what they may mean. But in this case, I'm then looking at the top 10 and then saying that I will focus the analysis on this giant connected component. And then if in this case, I'm not using Python, then I just output the graph in this GEFX. Is that the file format? The Gephi open source network analysis software has a format that but even a comma separated list of edges is also readable. So this is just like a raw visualization of the network, and I have applied in the Gephi software a modularity class algorithm, which according to a certain logic can provide information about things that belong together in clusters, which has to do with how tightly connected they are, basically how embedded they are in this sense. So even if they're connected to everything else, if they are tighter within themselves, so to speak. So we get this type of layout. And also with networks, I mean, for example, when I drew this, I just put them out randomly on the board. And that's also the case in network analysis. It's not like a coordinate system where you have a fixed position for this node, because it's relational, and then you use some sort of layout algorithm, which is often this of this so-called force-directed type or spring algorithm, where you basically get the idea that you have rubber bands between the nodes, and the layout algorithm tries to lay them out in a readable fashion with as little overlaps as possible. And then there are other layout algorithms which may focus more on like pulling clusters apart and so on. So that's the general sort of picture of the network structure, which says nothing basically. Lots of people did stuff, some did a little more, because the size here is in how many pairings of tweets and replies you are engaging. And then some are wider also, which means that they have communicated directly several times. So this basically says there were some people doing stuff, some did a little bit more, some did a little bit less, some did stuff a little bit more often than others, and people cling together somehow in some types of groups, but generally it's all like a giant hairball. But then we might filter the network, saying, for example, that let's just keep the edges that are above a certain threshold, like only if you're communicating with each other more than 4 times should we draw this edge, or only if there's a certain characteristics are sort of fulfilled or criteria are fulfilled, then they should be drawn. And I honestly don't remember exactly how this was filtered, but I tweaked the parameters in Getty and sort of found that once you filter down through the layers in the network, trying to remove like the noise, these 3 clusters that happen to be with my settings now, light green, darker green, and orange. I think my children sometimes say I'm colorblind, and I think I actually have a certificate that I have a defect color vision from when I was in 6th grade, but I say light green, dark green, and orange. Is that right? Sort of, yeah. And then we can also then zoom in to look at these. For example, you see the one on the left, the light green. If we show the names, the user IDs, we see that these are the Twitter accounts that reflect, I haven't looked into each and every one of them, but sort of the labor cluster. And then we look at the orange one, which is then roughly a Tory supporter cluster. So then it's an interesting question, like if we know that the two, those are the one of the green and one of the orange, which is the other one. Yeah, we can of course also zoom in closer on this, but it seems to be more of a activists, more like rebellious, what do you say, agitating type of cluster, which is about Brexit and UK Rebel Alliance and some tabloid and something called Robot Attack, and also BBC News Night and the Sun. It's something like some sort of arena for heated debate, maybe with a focus on Brexit. Which sort of indicates then that if we look at this Twitter exchange, we could say that, well, there were basically 3 clusters that seem to align around certain topics, not knowing anything else than the usernames in this case, that were formed around this. And I mean, this is just a general view, but then we can also move further, probably seeing that this one, the labor cluster, now I'm just doing this off the top of my head, I haven't really thought this through, but seems to be maybe a bit more decentralized. There are several large nodes that are sort of equal size, and there are some sort of things springing off and seemingly looking more like a decentralized network. If we want to be, we might imagine somehow that this is more centralized and less decentralized, because it has more of this sort of flower shape. But also, this is just now by looking at it visually with this particular layout algorithm, because we can also drill further with metrics, actually getting to know, like, what's the average of this and this metric, like what's the average betweenness in this network, what's the average degree, and how is the degree distributed. Like, is there a long tail? We can see something with the naked eye, but we can also look further at the network data and also generate like network data off of this edge list. Yeah.
And what type of knowledge we can grab from the visualization?
Yeah. I mean, we first and foremost we get knowledge about which Twitter users are important for communicating the different issues, and we get information about which users communicate with each other in groups that are tightly knit together, and which users never talk to each other. If we would go from this filtered view and back to this view, for example, with a more systematic analytical strategy, we could also find which users are bridging between the Labour and the Conservatives, and which users in this cluster seem to have the most like impact inside some of the other political clusters and so on. So this just is a very rough overview, like how to go from Twitter data to get a network picture. But then, I mean, once you have the network graph, you can then use like network metrics to calculate other stuff. Like you can run clustering algorithms, you can try to use different sort of measures of centrality, how important you are, how many connections you have, and then overlay that on the network as well. So you say like how different attributes that we can also enter manually from this list or other stuff that we have, like, is it the fact that users who post the most hashtags are the most influential, or is there a relationship between sharing many links and getting a central position? Yes, links are important in the Labour camp, but not among Conservatives. I mean, you can, depending on your research question, move forward in that type of manner. But then, this is a variation then of network analysis. ANT, actor network theory, or actor network analysis, is a popular theory in science studies and in sociology, mostly connected to theories of Bruno Latour. And it's a lot of literature to dig into. It's a whole field where you probably can say lots of stuff to provoke those who really are sort of dogmatic and believe in this theory and so on. But basically what it says is that anything is an actor. It's not only individuals, it's organizations, it's documents, it's legislation, it's technology. And when we study society, we should study it from the perspective of seeing it as an actor network, when everything that's a factor socially can be a node in a network. It's not only people, it can be a document or even an issue. So I'll show you how I developed a tool to try to do something with this. So instead of looking at who retweets who or responds to who, actually, I went to the text column and looked at the actual text of tweets, like this type of data, where you have the actual tweets. And then I created this very experimental tool that I call the thing linker, because it links things to each other. Yeah, actor theory is about how human and non-human actors are connected in relational systems. It sees entities, humans, texts, machines, I'm putting a spelling error here, activities, ideas as linked to each other in heterogeneous networks. And actors appear in any shape or material, and the important thing is not if technology and legislation have a human agency, but whether they have the capacity to cause difference in the course of action. Yeah? So this is a bit about the theory. So then I use a natural language processing, library called Spacy or Spacy. I see different pronunciations of this, which is one library among others who can do this. And I read the tweets. That's the first box. I add all the tweets to a data set. I clean the data from some stuff that we don't want. This is sort of a variation of the things I did before, removing numbers and web addresses and extra new line characters and stuff. Then getting a cleaner version of these tweets. And then, in order to link things with the thing linker, we need the things that we're supposed to link. So how do we get the things out of the text? And this is not something I invented. This is the thing in natural language processing and computational linguistics named entity extraction, where you have tools that can look at a text and algorithmically, it's a smart system. I don't know everything that goes on under the hood with these things, but it can, with quite surprising accuracy, extract things from the tag text and say that this appears to be a name. This appears to be the name of a place. This appears to be a product. This is talked about in such a context in this sentence that it appears to be a work of art. This appears to be a language. So if it says like speaks before, maybe it assumes that it's a language, but it's not about that. It's several different factors. It says this seems to be a country I live in, and then something with a capital letter counts, maybe. And it also extracts other things. Different tools extract different things. And what's interesting with this is that it's, when you run it on text, you get these types of things. And the thing you have on the rightmost column here is what it said in the text. And it says that labor seems to be an organization. It suggests, it says that Theresa May seems to be a person, surprising. Indian seems to be a nationality. NHS is an organization. Tomorrow is a date. 92 is a cardinal number. Both labor is an organization. Quite impressive. And also, actually, when I've done this on other tweets, it does quite interesting things where, for example, I've had the output where it says that Twitter is a place, and it says that Kardashians is an organization. So that's two good examples of how the actual use of it in context gives information about these things. So what I did then was that I used these tweets and I extracted the things that are talked about. Yeah, the things that are talked about. And then instead of mapping relationships, saying that when a source is mentioning a target, I said that within one and the same sentence, there is, or I filtered away all the words that are not things. And I also only kept some of the categories. I didn't keep cardinal numbers. I kept like some stuff like organizations, people, yeah, some of these categories that I thought were sort of politically interesting. And then I created an edge list programmatically saying that if NHS and both labor is mentioned in the same tweet, they have a connection. If Theresa May and tomorrow, even if that was in the category I filtered away was in the same, they have a connection. So instead then of getting a network of Twitter users, I got a network of phenomena that are co-articulated or mentioned together. Which means that we see, for example, that polls tend to be mentioned in the same tweets as general election, and liberal Democrats tend to be mentioned with UKIP, and Russia tends to be mentioned with Donald Trump and things like that. And these colors are also the modularity classes. So actually this is sort of a workaround where we can see these colored clusters as sort of topics as well, because it's connections, it's linked things that are linked through the aggregated like language use of people on Twitter. And then if we filter this down, we can say that, well, these seem to be the things that are mostly talked about in these election tweets. It's about labor, it's about Tories, it's about the leaders, it's about UKIP, it's about other parties, it's about the NHS, National Health Services, which was a big thing. It's about Iran and Donald Trump, it's about CNN, it's about Muslims somehow, the parliament. And if we zoom in further, we can see that, well, these were the actual key topics. And if someone would ask me then, what was the key issue? It was the NHS. Or maybe it's easier. We don't need to do this detour to see that. Maybe there are many other ways to see that this was the most important topic. So it's probably we should back off a bit and maybe find nuances within this, or maybe within this. But I mean, the network logic doesn't have to be just with users. It can also be with entities in
So when you zoom
language.
depending on the edge, right?
Yeah, this is filtering depending on the edge weight, like only show connections that have a weight higher than a certain threshold value and don't show the nodes that disappear when we remove those, or that are not connected to anything if we remove those nodes. So this is once again, I mean, also with the, I think with the Me Too stuff, it's not really surprising this. We could draw this without the Twitter data. We could guess just by reading the news that this was probably the case. But if we pose the right questions and maybe do a bit more refined stuff that takes some more time and it's more thought through, and if we really find the things that go maybe against what we would expect to see and drill down further on those places with these same methods, that's when it becomes interesting. So I mean, it's sort of maybe fascinating to listen to in a way, but also you end up with a question, well, why? We could have seen this. But I mean, then we have to translate this logic to where it maybe will make an analytical difference. Like, for example, staying with Donald Trump and saying he was here, what impact would that node have, like, in this discourse, for example, and what's the connection to Muslims, and how did that affect the election? Maybe the method would work better for a different issue as well. Yeah. Thank you.
So please ask Simon any questions.
Yeah. Yeah, exactly. Yeah, because with this thing linker idea, then there is no direction, because then they're just in the same tweet. But of course,
Yeah, so can I do it after, because we're going to have a longer discussion after my talk. I can mention it. Can you tell me where it is? Or are you leaving there?
I haven't, this analysis
Just mention it.
not
Write
have
down the
a
URL. No, write down the URL on the
network,
blackboard.
where you're saying that
Okay. Or
we
just,
don't just
yeah.
only draw this
No, no,
line
no,
between
just
A and B,
mention
but
it
we say
before
that
you
it has a direction. I mean, there's an arrow there, the A to C
just do it quickly.
also has a direction, and then C to D also has a
No
direction.
worries.
Then we, let's say, this is
Meeting.
maybe bi-directional. Then we open up for other possibilities in the analysis, for example, to have this, do walks through the network and see like which paths can we go, and we go from B, we can't go to A because that's directed, or what to B. So yes, in this particular analysis I didn't do it, but that's also like if you have the data about directions. Yeah. 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 Exactly, because I did this with the uprising actually in Libya on a data set during the Arab Spring, where I first tried to look at it as an undirected network, which showed that, for example, CNN and BBC and Barack Obama and most of these actors were very important to the network. But obviously, when you look at the direction, they didn't post anything themselves. Clearly, some of these people were saying, Barack Obama, why aren't you doing anything about this? Or CNN, why aren't you reporting? Which meant that the network was seen in a new light. And of course, yeah. And I think it's also a bit of a habit for me, because I started doing text networks where there is no direction in that sense. So therefore, I sometimes nearly forget about this direction when I actually have data about direction. So yes, of course, it adds more analytic possibilities if we have that. And sometimes maybe if it's mentions on Twitter, then we can get direction. Sometimes you can have data, for example, people that are posting in the same discussion thread on a forum. That is not such an obvious direction, because then you have to decide, is it a direction? If you post after someone, is that a response to the recent one, or is everyone responding to the first post, and so on? Yeah, so it's, you need to make sure that it is actually directional data, but as you say, in this case, it is, because I have this in response to. Yeah.
So I think we'll try to, I'm going to start continuing, so we'll have a joint discussion, because what I'm doing is a bit more related, almost the same, but it's just more mathematical. So before I do, Matteo is going to announce quickly about a course.
Yes, so if you are interested in these things, then next month we are actually giving the network science PhD course. It will be intensive 3 days, 24th, 25th, and the 28th of May. So plus a little to study to be done offline. If you're interested, you can maybe send me an email. Yes.
Sorry, what date?
24th, 25th, and 28th. But then I can send you a link that is too long now to. If you send me an email and you're interested to the course with the content, etc. The course is basically almost full. So we have maybe, I think, 3 places left. So if someone is interested, maybe send me an email. Matteo Magnani is the name.
Or just start a discussion and meet up, and we can chase them down.
Yeah.
Yeah.
Okay.
All right, I'm going to start. So what I'm going to talk about is something I've been doing for a while. Partly done with the help of Marie Curie as well, but mainly so it's called Meme Evolution Program, as I pointed out. And we're formalizing things like tweet transmission trees, Twitter ideological networks, from historical and live Twitter streams with incredibly precise mathematical definitions that I believe are legally tractable. That's our goal. So our Kolmogorov sample space is actually of a legal interest. So little omegas, that's kind of our goal, right? So we're not there yet, but we're starting the first baby steps. Right, so we are interested in formalizing emergence of echo chambers and all these notions people like Simon and David are studying, but in a very simple way, as simple as possible. Okay? So we are sort of ultimately interested in mathematical models of socio-psychological diversity, whatever this means, because part of the funding is from this French multinational, and we're sort of interested in stable immigration in France and things like this. And it's also heavily supported by AWS Cloud Computing Credits for Research, and then recently I have sort of this unlimited Databricks academic shard to continue collecting data. So this is how I'm collecting data for the Swedish election. What else? So there's a bunch of people involved. I should put Joachim Johansson and Olaf Björk, who's here as well, as part of this team. And yeah, so I'm mainly talking about this paper, which is a recommended reading, and it sort of is related to this more mathy paper. And here's the actual collection of about 21.7 million tweets for the US election that I'm legally allowed to share with you. These are the Twitter IDs, so anyone can go and grab these Twitter IDs to replicate my study and challenge me, you know, either academically or in a court of law. So here are some examples, right? So this is it's a bit of code that's all Apache 2 license, so you can completely commercialize it as well. So this is how I started, right? I was just sort of sitting around writing some software for some intelligence agencies and kind of could reverse engineer what was really going on what data is being fed. So I got really fascinated with it, and you know, it was not just social media. So you know, you can integrate this information across so many layers of your life, and then you get this incredibly fused perspective, a fused data set, where you can sort of have some kind of automated idea about a population of interest or a person of interest, and that's kind of the context I was entering this field from, right? So we started with this Kaggle data set. This was all back in 2016, and trying to make some. So this is a Databricks importable notebook. You can jump in, and we started trying to understand why is it so difficult for such powerful organizations in the world to get rid of ISIS. You know, it's a very simple question, and it's not trivial to answer. So here we formalize mention cascades, and you know, I don't want to get into it, but they're doing something very simple to actually not be ever, you know, Twitter can't just destroy them, right? And then I got into sort of extremist and multi-extremist followers network, because some of my friends were actually hurt in the pre-election, and I don't know. So then someone told me about the US Southern Poverty Law Center, which monitors all the hate groups. So we started sort of formalizing some kind of SPLC, Southern Poverty Law Center defined followers network of various hate groups, right? This is black separatists and everybody, you know, neo-Nazis and so on. So we started visualizing and realizing, okay, there's quite a lot of structure in these things. And this is just random samples of visualizations. It's just sort of starting out, right? And yeah, so let me just jump in to get into the talk right now. So this is, you know, about a couple years worth of work. We just submitted it last weekend. So I want to talk about characterizing the Twitter networks of prominent politicians and hate groups in the US. And this is joint work with a bunch of social psychologists. So this is Kumar Yogeshwaran, Kyle Nash, who's in Canada. These guys are in New Zealand. And then a whole bunch of other past students and researchers and others that's helping out of love, right? And we also have Matthias Gardell, who's the professor in the theology department. So he is sort of helping me with understanding the radical right in Sweden, or whatever you want to call it, Swedish groups with a certain religious persuasion. And I've just started, this is my summer reading for, so this is the Oxford Handbook of the Radical Right, which I highly recommend. So this comes from the guy in the Futures Institute that I think Simon mentioned, Jens Rydgren or Rydgren. So anyway, so if you're interested in this and you're in the math department, you can go to the Center for Multidisciplinary Studies and Racism seminars. So they have some interesting seminars, and they have free wine and cheese. So anyway, that's I'm just recycling this talk I gave earlier. So here is the 4 points. So what are the questions on the statistical experimental design? What is exactly the data and the statistics? Models and methods, and finally results. So question 1 is Trump preferentially retweeted? Okay, so retweet just means someone tweets and then I retweet them, so it's a public share of that tweet. So all my followers see my retweet of the original tweet. So is Trump preferentially retweeted by various types of hate groups as defined by the US Southern Poverty Law Center relative to other politicians? That is Clinton, who was running, challenging him, and then Sanders and Cruz. So these were the contenders, the second runner-ups. And we also threw in Paul Ryan because, he was Speaker of the House and wanted some control on the Republican side. And this is against the null random network model of apathetic retweeting. I'll formalize exactly what that means, the words apathetic retweeting. It's a very specific class of configuration models. Question 2 is, what frequency of unique users retweeted both a politician and a hate group more than expected under the null model? Okay, so that's a very simple question. And then question 3 is, what is the joint distribution of the degrees of separation to each user from each of the 5 politicians and the 8 most prolific hateful ideologies on Twitter, measured through the lengths of the most retweeted paths in the observed network? So this takes a lot of things Simon talked about, like betweenness, centrality, degrees of separation. So we're extending the classical notion of Milgram's degrees of separation, which is an undirected notion, because friends are an undirected relationship, but we can extend that to a directed notion of degrees of separation. So what we mean is, how many retweeter of a retweeter of a retweeter statements do I have to make to go from any user in the US, in our collection, to one of the influential ideologies or populations of interest. So I know how many retweet hops I need to make to go to black separatists, and how many retweet hops the same guy has to make to go to neo-Nazis or Donald Trump and so on. So each user will have 13 degrees of directed separations, with the hops, to characterize their retweet ideological profiles, which in turn we use to build these neighbor joining trees. That's what we call it. And we have to formalize them into forests because they're disconnected. Some networks are unconnected, like he was saying, there are many connected components. Forests are just a set of trees, right? A tree is just a mathematical tree. So this is what we mean by a retweet ideological forest. So it's a very simple statistic of the retweet weighted network he's talking about, right? So he's talking about reply networks, but I'm talking about retweet networks. So A retweets B, and then 8 times I put an 8 here. So these ideological forests are simply, distributed vertex programs whose output is these statistics, which are forests. And that is mainly used to explore the alternative space after we reject the null hypothesis. Okay, so the last question is, did the US hate networks get help from Russian trolls? Okay, so this is, so again, back to basics in the big data age, scientific hypothesis testing, right? 1901, Philosophical Magazine. Carl Pearson, right? Chi-square test. We're going back there. It's kind of lost nowadays. So this is Twitterverse. Twitter is a microblogging service. So, you know, you have tweets, and then there can be retweets of a tweet, which is a tweet. User can be mentioned in a tweet. A user can post a tweet. So when you post a tweet publicly and say, I cannot see what you're posting, you don't even know that you know what you're doing. Right? Anyone can see. It's a public post. So then users can follow each other, and there are hashtags or simply tags in the tweet. There can be links in the tweet, and then there can be tweets can have sources. So I can go to URL entities of newspaper articles. In fact, Mariama is here. She did a project last semester in this course where she was actually chasing the URL entities in the tweets of the UK election. I'll show in the last slide, and then grabbing the newspaper content of that thing and doing some topic modeling. So we collected basically about 22 million status updates. That's all communication events in Twitter. That's Twitter's own terminology. Status updates related to 5 politicians and 52 hate groups. And our experimental design is a combination of what we call retrospective REST-based data augmentation and standard public streams. And so we make our experimental design incredibly, under the control of the experimenter. So if you want to chase a subnetwork into the past, you can, and then you can come back, look at the stream, get insights, and chase another subnetwork into the past. And then all of that is completely transparent, so your entire collection strategy can be examined by other researchers. So this is essentially Southern Poverty Law Center. It has this thing called extremist files. It classifies hate groups by ideology, individuals or charismatic leaders and groups. And it maintains a running map of active hate groups and incidents. And so this is quite a bit about the map. And this is the number of hate incidents. And they basically, at this time, they had 18 US hateful ideologies: alternative right, anti-immigrant, anti-LGBT, anti-Muslim, anti-government, black separatist, Christian identity, general hate, Holocaust denial, Ku Klux Klan, neo-Confederate, neo-Nazi. I have to take a breath. Priesthood, racist music, racist skinhead, radical traditional Catholicism, and so on, and white nationalists, sovereign citizens movement. So, okay, whether you agree with the US Southern Poverty Law Center's classification or not is a completely different question. You can fight with their 40-year history of incredible details of why they classify, how they classify it. It's out of my domain. If you have your own public database of who you consider to be hate groups, I can just plug in exactly this algorithm onto your classification. So I'm not really that interested in, and even their definition of what a hate group is their own definition, right? So, yeah, so I think these are all debatable issues, and in fact, I don't know if I think, yeah, so I think they basically say, yeah, something like a hate group is one that maligns an entire group of people based on their immutable characteristics. If they cannot change something that they're born with, and then some group sort of maligns them, plans to whatever, put them in ovens, whatever you call it, then they're a hate group, okay? But they don't keep track of Boko Haram or ISIS or anything because they're only interested in US hate groups. So here's how the collection looks like. So this is on the day of the 3rd US presidential debate, and we're reaching around 120 events per second. So that's quite a lot of activity in Twitter. This is our live streams. You will be able to do this tomorrow, okay, on your own community edition. That's the whole point. So you should challenge me, okay? But I just want to be challenged purely mathematically, right? I don't want to. Words, no. Then we have to go to poetry jam. So the point is, we can all do this, and this is actually the last 2 days around the US election, right? This is the huge peak, so we reached about 140 events per second. So this is kind of the breakdown of various followers of the hate groups. So there's about 900,000 anti-government followers in Twitter, right? But and blacks supposedly are really into Twitter for some reason, so there's more blacks and everything. Blacks do, American blacks. So, but still, yeah, black separatists are quite high, alt-right, neo-Nazis, and so on. Okay. So then here are the 5 prominent politicians. So you have Donald Trump, Hillary Clinton, Bernie Sanders, Paul Ryan, and Ted Cruz. And what I'm showing you is the in degree, out degree, in neighborhood, and out neighborhood. So what I mean by out degree is the number of times someone retweeted real Donald Trump, at real Donald Trump. And out neighborhood is the number of unique users in our collector, in our sample, that retweeted Donald Trump. And same with Hillary. As you can see, the number of people that retweeted, unique users that retweeted Trump and Hillary are roughly the same, right? About 100,000 in the sample. But of course, Trump supporters are at least twice as active in the number of times they retweet Trump. So he really gets people going. In degree is basically number of times Trump retweets others. This is number of unique users that Trump has retweeted in the 9-week period, the public streams. And then this is for Clinton, right? So Clinton takes a bit more input. So anyway, I don't want to get you guys too much into these numbers, but just note that the other presidential candidates are highly dwarfed by the main ones. So this is data collected around the 9 weeks around the US election. This is the distribution of retweet. Remember in Simon's data, the number of retweets was a lot less than coded tweets, I believe, right? Especially in the beginning of the Me Too movement. So Twitter research basically says it depends on your design, what you're studying, what phenomena. These fractions of retweet, reply tweet, original tweet, quoted tweet, retweet of a quoted tweet, and reply of a quoted tweet. So these classifications, we will be using our SQL knowledge, right? That you guys already have in tomorrow's notebook. So we actually not only tell you this is what we call a reply of a retweet of a quoted tweet, but we give you the exact SQL logic from the fields in the JSON of the tweets that we're catching. So you can legally hold me accountable for how I call this a reply of that tweet, right? This is what I mean by the Sigma algebras must have legal resolution, right? So that's also important for everything we're doing in Project MEP. So we have 4.4 million distinct retweet pairs. So that means the original tweeter and the retweeter. So these are the users, right? And we have 2.7 million tweets, 13.7 million retweets, and then in total 22 million status updates, and 2.5 million unique users. So it's not a big thing, but as you will see, a lot of the algorithms we need to be able to do, we really need a fault-tolerant distributed computing because the jobs can take quite long. We're doing full-blown Monte Carlo simulations and everything at scale. So I believe for Sweden, Swedish election, we will have a lot more because we're collecting for 9 months now. That's the point. So we'll definitely need distributed computing for this. So here's a Trump-Clinton retweet network. Here are a few samples. I don't know. So this is C-post user screen name is the original post user screen name in retweet. So this is the original tweet that someone retweeted of Donald Trump. And real Donald Trump says China is cooking up conspiracy theories that the Olympics are rigged. Agent says Comey stood in the way of Clinton email. Anyway, this is Trump's standard thing from his golden toilet, right? Or whatever he does in the morning. Okay, this is kind of the resolution. So Trump-Clinton retweet network weighted by retweet counts are here. So what I'm doing is just the timestamp. So in our Poisson process interpretations, even for the simplest model, the timestamps are there, but we kind of do very simple first order things. So, but we do keep track of timestamps because we are ultimately interested in the continuous time markup process. So this is the days since the user was created. So we do some of these things to filter out bot accounts and stuff like this. Or we're only interested in people that have a historical presence in Twitter at least a couple weeks before the election or something like this. And then we have screen names and follower accounts. And then, Matteo's right, like the number of followers will change, the screen names will evolve, but then we have basic fielders for it, like by concatenation fielding or max fielding, whatever you need. And then this is just a sample, right? So this is Trump and Clinton's retweet network. So it's just all these people just retweeted Trump, and this is just a random sample for visualization in D3. Now this is from Gephi, which is way more richer. So this is the third US presidential debate, one of the most active days. And I'm just grabbing random 22,000 edges in this sort of Gephi visualized retweet network. So you see real Donald Trump here. And this is after a sort of standard community detection called the Louvain algorithm was applied. So it's just a heuristic that helps with visualization of what the major communities are. And then this is a 5% random sample of the retweet networks for October 19, 2016. So I'm just sort of trying to show you there is actually a time evolutionary pattern to these networks. The mathematical theory of stochastically varying networks on which messages are being passed is like, the set theory is not done. Basic combinatorics is like too much, okay? It's hard. Very clever people don't know how to do it. So it's open terrain for math problems as well. But I want to show you, so Louis Farrakhan is the main charismatic leader of the Black separatist movement. So because in our public streams, we're keeping track of all these 80-some hate groups and 160 accounts of these charismatic guys. So anything that they do, or their followers, or anyone does related to these accounts, we catch them up to what Twitter allows us to catch for free. Okay, so there is the sampling design. And that part of Twitter's how much they let you catch for free is proprietary, so we don't know. But it's supposed to be random. So it's a subsample of all activities, right? So this is again to point out that, do people know Tommy Lauren? Do you know Tommy? Okay, so she's a phenomenon, right? This is a Facebook phenomenon. Anyway, she's one of the largest audience ever in the US. It's really close. So she's from Texas, and I think her channel in Facebook is supposed to be more than like most mass media combined. So I threw her in. I like her. So and then there's others, Bernie and Fair Immigration, or an anti-immigrant group, I believe. And then, so of course the point is every day random samples kind of evolve. Okay. So now how do we do a little math? How do we make things very precise? How do we come back to null hypothesis, p-values, alpha levels, basic stuff? So for that we need a model. So I'm going to have this sort of a network. So I'm going to call aij equals 1. By that I mean I ideologically concurs with j, whatever these words mean. For me, it just means I retweets j. So that means information flows from whoever the original tweeter is to the guy who retweets or she retweets it. So this flow of information by the retweet direction. So that's all that is. So then just 2 retweet networks out of, so even for 9 individuals, there's a lot of possibilities, right? So you cannot do anything exhaustively. You have to, from first principles, start doing things probabilistically. So what we really want is in degree and out degree. So in degree is the number of edges that come to a particular node, and out degree is the number of edges that go out of a particular node. So for every node in our observed network, we have an observed in and out degree, right? So that is the number of times someone retweeted this guy, a number of times this guy retweeted someone else. Those in and out degrees in the observed network, I want that to be preserved all the time. Okay? So I want a mechanism to produce networks from the space of networks that preserves the in and out degree of the observed network. And that's called a configuration model. Okay? So the question is, how do you do simulation at scale from it? Is one of those challenging technical problems. But the original algorithm is from the original paper, so we're not doing any sort of algorithmic insights here. So it's called a random directed configuration model, and this becomes our null hypothesis H0. This is what we call, or the psychologists like to call, apathetic retweet network. Apathy, I don't care, basically, right? No pathos. So I'm apathetic because I don't care who I retweet as long as I get my retweets for the 9 weeks, right? I get 843 retweets, I will always get it, I don't care. So it's like drunk or apathetic retweeting. And also, others have to retweet me, right? So they, as long as someone else retweets me 560 times, then I'm happy, right? I don't care who retweets me either. So this is like absolute null model, simplest possible thing. So if we can reject that, then we say, well,
we have evidence, against the null in favor of its complementary space of all possible network models, right? So we don't want to say too much about the complementary space. At that point, I'm throwing my exploratory hat like Simon, and I'm starting to do forests and stuff like this, because I mean, that's exploratory. So here's my basic SPLC defined hateful ideologies as retweet proportions. So you can see neo-Nazis have a much higher retweet to original tweet ratio. Same with anti-LGBT. And this is this is for the Clinton camp and the Hillary camp. So I think 0 is Trump's cluster, and 2 is Clinton's cluster. And what you're seeing is that if you just look at this at face value, blue is 0, so it looks like people in Trump's cluster. Okay, the cluster was done using a very simple community detection algorithm. In Trump's cluster, seem to be more actively retweeting hate groups. But the problem was when I sort of started talking to these psychologists, they were kind of here, and there were these papers by, I don't know, computational somebody, psychology or whatever, and they were all debating about, these are papers from Berkeley and stuff, right? They're all math departments. But they were all debating about, we cannot do the chi-square test, and because we have to control for the in and out degrees, Trump has just had higher activity levels, so it was just a lot of methodological, I don't know, maze, because they were correcting for the chi-square test by like the node degree, and it was very heuristic. There was no probability model under the hood. So I thought, okay, this is a simple problem. Let's just a very simple thing. So this is now the log base 2 of the number of retweets of real Donald Trump, and log base 2 number of retweets of an SPLC defined hate group. I'm simply giving you these just ordered pairs of log base 2, and I'm just showing you for Trump what the marginal distributions are. And when you look at Hillary, there's hardly any action. So visually, no one's going to fight, right? It's obviously much more active, but of course, this is just because Trump is popular, right? So this was sort of the same. You can look at every single ideology, and you will see that Trump is much more, Trump supporters are much more, people who retweet Trump and retweet a particular hate group are very prevalent and very active. And this is compared to Hillary's. Yeah?
So the data you are showing,
yeah.
It's sample data or it's simulation?
No, it's all real data. So there's no simulation right now.
Okay.
Yeah, we only do one simulation to get the p-value in there.
Yeah, because you have talked about the space of possible networks.
Yeah. So we'll come to that. So right now there's no simulation. Yeah. And I'm just showing you, this is the statistics the social psychologists and political psychologists are working with. They were interested in, right? They study intergroup conflict theory and blah, blah, blah. So they wanted to know, well, anyone they showed this picture to, they're like, well, it's obvious. There's nothing going on with Clinton, a lot going on with Trump, and then they were sort of in that. So then when I and then this is sort of the chi-square test, and chi-square test is obviously very, the p-values are so small. And so, but then we wanted to do something more than that, so let's get into this algorithm, right? So what I want is a distributed, scalable, fault-tolerant sampler, right? So I want my algorithm to work even if I have 800 billion nodes, as long as I have enough money in Amazon or SNCC to carry out the computation, even as machines fail. So that's what Spark comes in. And that was our requirement for everything we do in Project MEP. So then the directed retweet edges are our 2 columns. So we have the tweeter here and the retweeter here, right? So we have each retweet like this. And then you can also have another view of the same network as a multi-edge self-loop retweet network. So that means you just slap them together, right? Because the oranges are the same. So it's the same view, but then we keep this view for vertex programming, which you will learn tomorrow. Okay, so now I have my sample from a directed multi-edge self-looped configuration model. What is this? This is the thing that has to preserve the in and out degree, right? So step 1, you cut it. You just simply go and snip. This is the original algorithm by Watts and Strogatz and those guys. Actually, yeah, Strogatz was my mentor at Cornell as well. So, and then when you cut it, and then the next step is you permute it. So you take the These are called in half edges. And then you permute this, right? So which means you put a pseudo-random number, associate a pseudo-random number with it, and then you sort it according to the pseudo-random number. So that's why I remember I said sort is one of the most primitive algorithms, and modular arithmetic for pseudo-random number generation is they're equally important. So that's all I'm doing. So then these will get jumbled. So here I've basically turned them around in reverse order. So this went here, just to make it simple. So 1, 2, 3, 4, 5, 6 went to 7, 6, 5, 4, 3, 2, 1. And then I rewire. Right now I just connect these things. So it's now. So now I have a realization. Now the beauty is after these 3 steps, the in and out degrees are preserved for every node. Okay? By construction. So that was the original network, and this is our sample network. And you see the in and out degrees are preserved. So is that clear? So this is now producing independent samples from the configuration model, which is our apathetic network model. Okay. So now is the question. So make sure you guys are paying attention. So what is the probability of the sample network? Those who are looking at the slides shouldn't answer. Yeah?
1 over the number of permutations.
Yeah. So that's a good answer. So 1 over the number of permutations is nothing but 1 over the number of the retweet factorials, right? So 1 divided by the factorial of the number of retweets. So that's a big number, but of course we can use the Monte Carlo algorithm and get consistent estimates of this p-values. Okay, so that's. So this is essentially, I don't want to explain this in English. Okay, this is just the algorithm in words. But what we do is now we interpret the independent and identical samples as those from the null model H0, right? Which is our apathetic retweet network model. Okay, so this is my sort of, Trump says this is reality, folks. This is not reality, folks. Okay, so then the next main mathematical idea is actually very simple as well. So we want to go from the directed configuration model to what I call the geometric retweet network, right? This is going to formalize a lot of things Simon's interested in, or betweenness and centralities, and it's actually a sort of very extreme look at the Markov chain that's formalizing retweet transmissions. So we'll see. So what I'm doing here is I take a multi-edge self-loop retweet network, and then I turn it to a weighted retweet network. So I just put integer 2, there are 2 edges, nothing going on. And then what I do is this little magic. 1 over 1 plus the number of retweets. So now big numbers become small numbers, right? 2 becomes 1 over 1 plus 2. So there's a probabilistic justification for it, but this is the interpretation, right? So in a geometric retweet network, the shortest directed path from A to B is the most retweeted path, okay? In a sort of very intuitive sense, because I'm using this inverse proportionality. Now, why should I use 1 over 1 plus number of retweets? Why can't it be 1 over whatever, 800 plus? I don't want 800 plus, well, it will destroy the signal. But the reason is it's actually connected when Dijkstra, right? So people know about Dijkstra's algorithm for shortest. So when Dijkstra meets Poisson, whose expectation is a random exponential with observed number of retweets as its mean parameter. So that means I want to be able to do shortest path algorithms on this huge network, because I have this Pregel API, which you'll see tomorrow, that allows me to implement this at scale, which means I can find the shortest distance from every node in a very, very large network that has to be distributed in random access memory across lots of machines, right? I can find the distance from every node to a particular source, a single source. So this could be some neo-Nazi hate group or Donald Trump or anyone, right? Anybody of interest.
So to be able to do that, that's called the distributed Dijkstra algorithm using a Pareto program. I need shortest paths. So I don't want to go directly after longest path. Actually, longest path problem is a little fine. But then the probabilistic justification is that if I look at a Poisson random variable, which just gives me counts, 0, 1, 2, 3, and I say my Poisson random variable does not have a deterministic mean, but it has, the Poisson random variable's mean parameter or expectation parameter is actually a random variable, which is the exponential random variable, whose mean parameter is the number of retweets. So it's just one level of mixing. And then it justifies this 1 over 1 plus thing, right? So what, at the end of the day, I can go from an empirical geometric retweet network plus distributed multiple source shortest path vertex programs, which you'll see by the end of the day tomorrow, into asking things like this, the so-called where am I operator, right? So how do we get here? We get here because from the shortest paths, I'm able to do this magic, right? I'm able to ask, here are all my sort of influential nodes of interest. So this could be Donald Trump, Hillary Clinton, and so on, maybe neo-Nazis. And so in my example, I have 13 of these, 5 politicians in 7 groups. And then here's user 1. So for user 1, I have these integer. Okay, I'm very close to Trump. I'm 3 degrees from, I'm maybe 13 degrees from neo-Nazis and so on. So there's this integer vector which tells me the directed degrees of separation simultaneously to multiple populations of interest. So I use that. I call it we call it the retweet profile, ideological profile, and each one comes from the shortest path thing, right? So now I have U2 and lots of users. So now I look at the pairwise Manhattan distance between every pair of users, and that pairwise distance becomes input to this neighbor joining population ideological forest. That's the main idea. Okay, so I'll show pictures just to. So here's interest of time. So here's basically my observed statistic. So here I'm asking what's the relative frequency of retweets by any one of the hate groups or their leadership for any original tweet made by one of the politicians. Right. So that means 98.7% of all people associated with hate groups, according to the U.S. Southern Poverty Law Center, retweeted Trump, right? And none retweeted Hillary, Bernie, Paul, or very little Ted Cruz. And then this is my null distribution. This is my acceptance region from my random configuration model, right? From my null model of apathetic retweeting. So if people are apathetically retweeting, and we preserve the activity level of everyone, not just Trump, then you will only get a number between 0.6, around 0.6 under this. So this, if it falls here, then it has a acceptance. It's in the acceptance region. So it's way above the acceptance region, and these are way below the acceptance region. So I don't want to go too deep into interpreting the alternative space, but we kind of can interpret this as preferentially non-apathetically retweeting, right? This is de-preferentially or non-preferentially, whatever. I don't want to get into words, but there is a clear signal whether you fall on the above or below this acceptance region. And then we do something a bit more. So we go 1 degree deeper and we ask what's the number of unique users who retweeted a politician and a hate group at least 5 times each, right? So this is a very strong signal, right? So these are people that are retweeting once a fortnight in the 9-week period at least, and they're immediately retweeting at least one politician and one of these 80-some hate group accounts. And what you notice is that for Trump, it's a lot higher than others, right? So for alt-right, anti-government, anti-immigrant, anti-LGBT, anti-Muslim, and so on. So now the question is, what is the acceptance region around these numbers, right? Under the apathetic retweet network model. Is this surely caused by Trump's activity levels being very, very high? So once again, here's the actual observed statistic and the null distributions, acceptance regions. So you can see for all the ideologies except black separatists, the observed number of unique users who retweet both Donald Trump and one of the hate groups is significantly higher than you would expect under the null model. And then if you look at, I don't know, let's look at Bernie, even Hillary,
circle means that they fall below the acceptance marginal, and star means they fall above. So, you know, it's making sense. And the really cool thing is this sort of native control. So the black separatists are consistently non-apathetically retweeted, but in a preferentially, you know, disapproving manner or whatever. So it's always below the acceptance interval for every politician, right? Black separatists don't like any other politician, which is kind of interesting, right? I won't read too deep into it, but the point is we actually can be quite comfortable that this pattern is not completely some chance, right? Because I am showing this in a log plot, by the way, this is power of 10. So this is not like if under an apathetic retweeting network model, these are significantly, you know, so significantly extreme numbers. And then this is the ideological tree I try to draw for the next couple of minutes. So basically, I'm only showing you around the top 95% of the population that is summarized by these integers, which are, each integer is the shortest retweet path, most retweeted path. The length of the shortest, most retweeted path to Donald Trump, to Hillary Clinton, and so on. And what this is showing is approximately 2% of the population, which is 42,853 users in our sample, have this ID 05, and it's this little node in this purple clade, leaf node. And this is 7, and this is 12. And if you note these guys, you see they're kind of equally close to Donald Trump and one of the presidential candidates. So we really put them in a purple clade, they're not red or blue. Right? And then here, if you see this is the most, the top 95% of the population, up to the resolution of 7 integers to this tree building process. We can see that these are all sort of more, what do you call them? Hillary, democratic leaning clade is what I call them, because these are mostly ones. And then if you look at these, they're kind of farther away from all these hate groups in general. And so that's the sort of democratic clade. And so they make up, you know, a good 40-some% of the population, or actually 50-some% of the population. And then this is that Trump clade, or the Republican-leaning clade. So they generally have, you know, far away from Hillary and Bernie in general, but close to at least one of the Republican candidates. And I think what's sort of, the only thing here is, you know, in the top 95%, the only group is anti-immigrant group comes on the top. And it's this particular clade, clade 14, which is sort of on its own, and it's very close to Trump, but far away from the other Republicans. And but all the other clades with the 1 for any of these hate groups are really in the bottom 3%, which to me is mind-blowing, right? Because most Americans who support Trump are actually not very actively involved in any hate group, which to me is interesting news, actually, right? So that's what. So these plots are zooming into that small 5% and trying to show you the cumulative percentages of the monitored Twitter population broken down by each politician and each hate group. And what I'm plotting in the x-axis is the ordered pair of the degrees of separation from a politician and the degrees of separation from leaders of a particular hate group. So this is anti-immigrant group. You can see Trump is really dominating here. And I'm going to kind of skip this in the interest of time. You can read the paper if you want. So the significant statement is basically this. During the 2016 US presidential election, there was significant debate on whether Donald Trump's campaign was fueled by hate and bigotry toward minority groups. We analyzed nearly 22 million communication events on Twitter to better understand the networks of retweeters of American hate groups and 5 key American politicians during the last stages of the election. Our data reveals that Twitter users linked to various American hate groups, including anti-government, anti-immigrant, anti-LGBT, anti-Muslim, neo-Nazi, and white nationalists, were more strongly linked to Trump over any other politician. On a very seemingly hopeful note about the American people, only a small fraction of those within 3 degrees of separation from real Donald Trump during the 9-week period are also within 3 degrees of separation from any hateful ideology. And why did we draw 3 degrees of separation as a cutoff? Because that's where black separatists actually become close to Trump, and so our null hypothesis rejected it, so it's simply something in the alternative space we will refuse to explore. So that's a nice thing about coupling, you know, basic hypothesis testing with exploration. So now, did trolls from the Russia have an effect on our test? Coffee still arriving, so this is coffee. Hey, so Coffee's still arriving. So I just did this as a project in my own course last semester because I told students to do a project. I should do a project. So I just saw this news, and we have this 2,752 Twitter accounts that were released, right? Belonging to this Russia's Internet Research Agency. So what do you guys think? Did trolls from Russia have any effect? I mean, I think what we found is actually not surprising. So we actually know the trolls had no effect on our subgraph because the corner of the Twitterverse we're looking at, even if there was a Russian troll farm and whatever is going on, with these BBC documentaries about Putin, but even if there was, their mandate was to convince people who are on the fence. So these guys won't show up here anyway because these guys are already converted. So we had no effect. In fact, the observed statistic didn't even change by an integer. The entire vector didn't change. And the Monte Carlo error was standard Monte Carlo error, so there was no change at all. And then we control for bots as well because the reviewers were like saying, oh, you should control for bots. And we kept arguing, no, we don't want to control for bots. Bots are affecting stuff. We want to observe bots. But then we checked if our test was sensitive to the removal of bots using standard bot detection algorithms like low entropy scores and things like this. So and then this is for the UK election. I'll shut up. So we've done exactly the same thing for the UK election with ideological trees. This was done mostly by Joachim Johansson. And this is where we had to formalize forests because Theresa May is like her own world. We could never connect her to anything. But maths is easier, so we just have forests to ideological forests. I think I'll just stop. Sorry, I kind of go over a few minutes. Yeah, coffee's here. So if you guys want to ask questions, just ask, and people can start getting coffee, and this is the pita bread. We got this kilo called the red morning, so I was yeah. I read it quite and I got it right on the yeah, exactly. The in and out degree, right? No, because if there was, this is so you got absolutely apathetic. We destroy the structure, and then we can say what we observe is, because these are statistics anyway, right? What are all the users that retweet at least 5 times the statistics? Very complicated, but then we can get the null distribution from these simulations. and then say, I'm really apathetic. Yeah, exactly. So that's classical 1901 stats. This one's 1920. It's called generalized Fisher's exact test. What I'm doing is generalized Fisher's exact test. Yeah. Yeah. I'm listening. Go on.